Hello guys, this is T. Keertana from Department of ECE, Venkateshwar College of Engineering. So on my channel, the next topic we are going to discuss about antennas and type of antennas, application of antennas. So what is antennas actually? The brief introduction of antennas. Antennas are devices that transmit or receive electromagnetic signals enabling wireless communication. So these are normally wireless communications like transmitters, etc. So they are essential components in various technologies from radio and television to cellular networks and satellite communications. So, what are antennas? The definition of antenna fundamentals, and diverse antenna designs. So, here antennas are devices that convert electrical signals into electromagnetic waves and vice versa. So electromagnetic waves, in the sense, the waves normally will convert into electric field to magnetic field, and magnetic field to electric field, return vice versa. So enabling wireless communication and data transmission. So there is a data transmission takes place in these antennas. So antennas fundamentals. Antennas operate by radiating or receiving electromagnetic energies with their design and materials, determining the directionality, frequency range, and efficiency of the process. Then I have diverse antenna designs. Antenna come in a wide variety of shapes and sizes, from simple dipoles to complex phased arrays, tailored for specific applications and frequency bands. Then I have fundamental antenna parameters: wavelength, radiation pattern, and directivity. So the wavelength of the electromagnetic waves determines the size and design of the antenna. So here we cannot determine the exact wavelength of antenna. It completely depends upon the size of the antenna and the shape. So antennas are present in different shapes, different size, and different design. So based on that, the wavelength can be taken. Then radiation pattern. The radiation pattern describes the intensity of the radio waves transmitted or received by the antenna in different directions. So even the radiations also, in which direction the antenna is present, based on the directions. So these radio waves, the intensity of the radio waves will be transmitted or received. Then directivity. Directivity is a measure of how focused the antenna's radiation is in a particular direction. So directivity is nothing but, oh, in one direction, how focused it is and how much intensity it is calculating. So this is the directing. Directing is nothing but the how the antenna's radiation is in a particular direction. Then we have dipole antennas. Dipole antennas are one of the simplest and most common antenna types. So these are the one of the type of the antenna. They consist of two equal length conductors, typical metals, rod or wire, positioned end to end along a central axis. Dipole antennas are widely used for radio and television broadcasting as well as in wireless communication devices. So as it is shown in the figure, there is a rod in between this, and the wires are connected. So this is end-to-end connection. Dipole antennas are widely used. So these are the dipole antennas. So they are widely used in radios and television or broadcasting as well as in wire. So these are the wireless connections. So it connect the wires around the rod, but it will communicate. The transmission of data takes place wirelessly. So the length of the dipole is typically one half the wavelength of the single. It is designed to transmit or receive. This configuration allows the antenna to efficiently radiate or receive electromagnetic waves, making it a versatile and widely used antenna design. So next we have monopole antennas. Monopole antennas are a type of omnidirectional antennas that consist of a single conductor, usually a metal rod perpendicular to a ground plane. They are commonly used in mobile devices, radio, and wireless networking due to their compact size and wide coverage area. Then I have monopoles can be designed to operate at various frequencies and are often used for applications such as cellular communication, Wi-Fi, and AM, FM. That is amplitude modulation and frequency modulation radio transmissions. Also, it is used. This is the monopole antennas, and then we have patch antennas. Patch antennas are a type of planar antenna that consists of a metallic patch placed above a ground plane. So they are compact, low profile, and easy to fabricate, making them popular for applications such as mobile devices, satellite communication, and radar systems. Patch antennas can be designed to operate at a specific frequency and polarization by adjusting the shape and size of the metallic patch. They offer a relatively narrow bandwidth but can be easily integrated into various electronic systems. Then we have parabolic antennas. Parabolic antennas are parabolic reflectors, highly directional, and microwave applications. We have some. So parabolic antennas use a curved dish-shaped reflector to focus electromagnetic waves, providing high directivity and gain. Then the parabolic shape ensures the signals are in phase at the focal point, maximizing the antenna efficiency. Then highly directional. Parabolic antennas have a very narrow beam width, allowing them to transmit and receive signals over long distances with high precisions. So this makes them ideal for satellite communication, radar, and other point-to-point applications. Then we have microwave applications. The parabolic shape of these antennas allow them to operate effectively at microwave frequencies, making them a popular choice for applications, satellite TV, wireless into and microwave links. Then we have Yagi Yagi-Uda antennas. Yagi-Uda antennas are a type of directional antennas known for their high gain and directivity. So they consist of driven element, a reflector, and a multi-directors arranged in a specific configuration to focus the beam and maximize signal strength in a particular direction. Yagi-Uda antennas are commonly used for radio and television reception as well as in wireless communication systems when they provide long range, high performance signal transmission and reception. Then I have antenna applications, communication systems, radar and satellite, navigation and localization, then broadcasting and internet. Antennas are essential components in radio, television, and wireless communication systems transmitting and receiving signals over air. Radar system and satellite communication rely on specialized antennas to detect, track, and communicate with distant object and spacecraft. The navigation and localization. Antennas are used in gas, GPS and other navigation systems to pinpoint locations and guide vehicles, ships, and aircraft to their destinations. Then I have broadcasting and internet. Broadcast towers and Wi-Fi routers utilize antennas to distribute radio, TV, and internet signals over wide areas. Then I have conclusion. So this is the last conclusion about the antennas. In this presentation, we have explored the fundamental concepts of antennas, their various types, and their diverse applications. Then I have antennas are critical components that enable wireless communication, enabling the transmission and reception of electromagnetic signals from the ubiquitous dipole and monopole antennas to a more complex patch and parabolic designs. So we have gained an understanding of the capabilities of use cases of these technologies. As we conclude, it is clear that antennas will continue to play a pivotal role in the ongoing evaluation of wireless systems and communication networks. So this is what this is all about the antennas, and so thank you.